Welcome! Today we're going to dive into something that's, well, kind of the fundamental map of all of mathematics, the number system. It's the language that describes our entire world, and we're going to build it together piece by piece, right from the ground up.
Okay, so let's just jump right in. We all learn how to count, right? 1, 2, 3. But that's really just the first page of a gigantic book. The real question is, what happens when we go beyond that? What does the entire universe of numbers really look like?
To figure that out, we have to start at the very beginning. We're going to meet the whole number family, starting with the most basic, the most essential building blocks of all of math.
First up, we've got the natural numbers. You know these. These are the first numbers any of us ever learn. Your classic counting numbers. If you can count it, it's a natural number. 1, 2, 3, 4, and on. Simple as that. But our little number universe gets a whole lot bigger with just one simple addition. What happens when we take all those natural numbers and we add the idea of nothing? We add the number 0, and bam, just like that, we've created a new set, the whole numbers.
Okay, but what about concepts like being in debt or temperatures that drop below freezing? For that, we need opposites. We need to go backwards. So, by taking all of our whole numbers and giving each one a negative twin, we create the set of integers. Now we can move forwards and backwards from 0.
So here's a really great way to picture all this. Think of these number sets like Russian nesting dolls, or a bunch of bags stored inside each other. The natural numbers are in the very smallest bag. That bag fits perfectly inside the slightly bigger bag of whole numbers, which then fits inside the even larger bag of integers. Each new set we've talked about contains all the ones that came before.
Alright, so where are we going with this? Well, we're building towards the numbers we probably see most often every day. I'm talking about fractions and decimals. This brings us to the great organizer of the number world, the rational numbers. Now, for any number to get into the rational club, it has to pass a simple 3-point check. First, can you write it as a fraction? One number over another. Second, are both of those numbers, the top and the bottom, integers? And third, and this one is a really big deal, is the bottom number, the denominator, not 0? You can never divide by 0. If a number checks all 3 of those boxes, congrats, it's a rational number.
Okay, time for a little pop quiz. Let's test this system with a tricky one. What about the number 0? We know it's an integer, but can it pass our 3-point check and become rational?
And the answer is a huge yes, absolutely. Because we can write 0 as the fraction 0 over 1. Let's see, is it in p over q form? Yep. Are 0 and 1 both integers? You bet. And is the denominator not 0? Check. It passes with flying colors. This is so important because it proves that all integers, and so all whole numbers and all natural numbers, are also rational numbers. That nested bag just got even bigger.
And this leads us to a really cool discovery, kind of like a secret identity. It turns out that every single rational number, when you write it as a decimal, has one of 2 very distinct personalities. On one hand, you have the terminating decimals. These are the nice, neat ones. The division process just ends. It comes to a clean stop, like 7 divided by 8, which is exactly 0.875. Done. On the other hand, you have the non-terminating repeating decimals. Now these guys look like they go on forever, and they do, but they aren't random. They fall into a predictable repeating pattern, like 10 divided by 3, which is 3.33333 forever. And that right there is the key takeaway. That is the one simple rule. Rational numbers are orderly. They are predictable. When you turn any rational number into a decimal, it will always do one of those 2 things. It will either come to a clean stop or it will repeat a pattern forever. There are no exceptions.
So this brings us to a really fascinating question. We've just established this rule, that rational numbers are totally predictable. But what about the numbers that don't want to play by the rules?
So I'm going to leave you with this final thought to chew on. If the rational numbers are the ones whose decimals either stop or repeat, what do we call the rebels? The numbers whose decimals go on for infinity, never ever ending, and never repeating a pattern? Well, that's a whole other family of numbers, and that's a story for another time.